Hi, I'm TomTom, and I make games. In this video, I'm going to teach you how to write scalable, manageable code for your games by showing you the source code of my most recent one. This is an intermediate tutorial, and there's going to be special focus on project and code structure. If you feel like you worked with games for a while and have worked on a lot of projects but struggle with keeping track of your project and get tangled in your own code, and never seem to be able to finish projects because of it, or can't read your own code in a little while after writing it, this is the perfect video for you. I'll also briefly talk about scaling, prototyping, and game design aspects of the project, especially at the beginning, but coding is the main focus of it. This project was made in Godot, so the tutorial is obviously in the context of Godot. However, the underlying principles of the project are game programming patterns and can be applied to any engine or language. In order to understand this video better, there are some topics you need to know prior. Here's a list of them. Thorough understanding means you have to have a deep understanding and personal experience working with these topics, and surface levels means you just have to know what I'm talking about. A short skim through documentation or articles about it will be fine for those. Finally, if you want to have access to the source code yourself, it's available on my Patreon, link in the description. Alright, that's enough yapping, let's get started. Let's demo the game. I'm gonna use an application called Screen Copy, which shows the screen of your phone on your desktop, since the game is made for the phone. So as you can see, my phone responds to the input, and you can see the input on your screen. So this is the menu of the game. There's the title of the game, the play button, and links to my socials over here, these three buttons, as well as, if you listen closely, you can hear there's music in this game, and this music was made by my dear friend. There's his name and socials as well. And finally, there's the button to toggle the music on and off. So I'm going to keep the music off for now. As you can see, we control the big blue thing, and to the proton are there are electrons that are attracted to the proton gravitationally, and then there are neutrons that we have to destroy. Oops. And as you can see just a second ago, if we touch the neutrons, we get destroyed, but we can smash them with the electrons instead. First of all, we have to kind of smash them at a particular speed, so just touching them wouldn't be enough. And they have a little bit of health, so they need to get smashed quite a little bit, but you get feedback when you smash them once or twice. And as you can see, they also respawn, and there's a score meter at the top left corner. And that's about it. It's an endless game, so you play until you die. And when you die, you restart. That's about it. So I started making that project a little while after I finished like half of a game programming course that I was enrolled in at the time. I had some clear goals with this project. I have learned a lot of code organization in game development from that project, and I wanted to apply it to an engine that I already knew, first of all. Second of all, I wanted to kind of widen my portfolio. I learned a lot of things on that project and learned that I was doing a lot of things wrong with my code, and I wanted a portfolio that I was proud of. I wanted to make a game that I could show to someone and say, hey, this code is good. Because like if I was looking for a job and I showed my old code, I would be like, by the way, I don't write code like this anymore, just so you're clear. And you know, it's kind of it's bad. Yeah, that, and also I figured it was about time to make another game. So because of this, I didn't want to go for something big. I wanted something that I could finish in a couple of months max. If I went for something big, I might not finish it again, and then I would have nothing to show for. Plus, the main goal with this project was organization, making sure my code was, and my game was coherent and cohesive, and that different parts of the code interacted with each other in a way that made sense. And I didn't want to go out and learn new things beyond that. I just wanted to get some practice in something that I already knew, just get comfortable with it. So with that, I started prototyping, and my first prototypes were actually on paper. The inspiration I vaguely had for the project is dice. At some point, my friends and I purchased colorful D&D dice, and like they were all different colors, and I really liked rolling them around because they looked really pretty when they were rolling around all colorful, and I liked to like grab a bunch of different colors and shake them around and throw them. So that was kind of the inspiration, but that wasn't also the only inspiration. I just knew right away I wanted to go with a mobile game because mobile games are, usually easier and smaller, and I could get away with a lot of things in mobile. One idea I had, again, the marble balls, which came from the colorful dice. Another idea was like a kind of puzzle game that where you'd have an AI that you made paths for. You would kind of have this circular circular map, as you can see here, that you would kind of rotate, and maybe you would have to get one girl to another and the AI. But then I thought about it more, and first of all, the rotation would be the rotation itself wouldn't be complicated, but the different rotating pieces and the pathfinding for this with rotation would get really complicated really quickly. And I just knew that I couldn't go with two ideas. I needed to come up with more and then pick the best ones out of the bunch, because I've also been learning some game design, and I'm a firm believer that the best game is one that hasn't been made yet. Because of that, I always go for more and more ideas. Maybe I can come up with something even better. I didn't end up doing that in this case, but I have done it before. So here you can see me writing some words down, and maybe that would bring me to some ideas. Yeah, it didn't get me anywhere really. Another idea I had, which is also a rework of an old idea, was two players connected with a string, but that kind of didn't lead anywhere. Then I thought about maybe a simulation game where you build small towns, and maybe there are small little guys, just people walking around, but I thought simulation would be way too complex for this. And I just kind of kept going to the marbles thoughts. My mind kept going to it, and I felt like that was both most solid idea as well as the easiest to execute, which then led me to my digital prototypes. So the first digital prototype was just a ball pit. Again, I tried to capture that idea of marble balls rolling around, try to figure out what was so fun about them. You can just, again, this is just like marble balls spawning and flying around, and you can pick one up and throw it, which was pretty fun, but not a full game. So I decided to keep thinking about it, which led to my second prototype. So this is prototype number 2, and the main difference between this one and the other one is magnets. Starting from this prototype, I was actually using paper prototyping and digital prototyping sort of in parallel. This idea was born on paper first, and I have a game design notebook that you saw just a moment ago, and I take it everywhere with me, and whenever I get an idea, I write it in that notebook. So yeah, this idea was born in the notebook, but then I decided to test it out real quick because there was no use of testing it out on paper, since this is a very digital based prototype, I guess. Like, it's hard to, the whole point of it is the physics engine, which can't be replicated on paper. But yeah, I really like how the objects stick to the magnets and how fun it is to move them around with magnets. But the point of this prototype was to get these marble balls, again, over here, which did not turn out to be fun at all because they fall really easily, and it's really frustrating to get them over there. And instead, it is really fun to watch them scatter, which is a bad thing. You don't want losing to be more fun than winning in your game. So it was back to the drawing board, and I went on to create the third prototype. The third prototype was just, I went in a completely different direction. I thought if getting the marbles from point A to point B wasn't fun, and it was instead more fun to watch them move around, how about I make the game about arranging them instead. And in this prototype, you had to arrange those stars into constellations with bigger stars. Again, they're attracted to the bigger stars, which came from magnets, and then you have to kind of make constellations with them. And I really like this prototype, and when you start liking what you're doing, it's really, really bad because you might not be able to see the flaws in it. So I sent this to my friend, and I let him just kind of try it out, and it was a fun idea, and he liked the thought of it, he liked doing it, but it was really frustrating to get these tiny little stars to arrange, even when the players seemed to be doing everything right. I was just sort of going with Godot's built-in physics engine, but if I ended up going with this, I would need to sort of make my own code to make sure that when the player arranged the stars right, they would kind of fall into place and kind of write all the logic for that, because the way it was with the default Godot physics engine, it was really frustrating and not at all fun to arrange the stars in the right way. Prototype number 4 was actually the final one. So I thought that since it wasn't at all fun to move the stars into place, like still it wasn't it just wasn't fun. It was frustrating, it was hard. I would have to write a lot of really hard code to make it work, and I lost that kind of scattering aspect of the game, and which was the most fun part. The most fun part of the game was to watch the little pieces scatter, and because of that I kind of went back to the scattering colorful marbles thought, and I thought, what if I made the whole point of the game scattering them around? So the way I decided to make that, the way I decided to make that the main point of the game is I added enemies that would have to be smashed with the little pieces and the little stars they were at this point, I guess. That would make the whole point scattering them and watching them go in all different directions. And this was much better, this was much more dynamic, but as you can see, like, it's fun to watch them spread around, but as you can see, the enemies are really, like, annoying first of all, but also it is annoying to move the main star that attracts them all, and also the little stars kind of don't listen to you, so I worked on quite a few variations of that until I settled on this one, I believe, and I even made 2 versions of it, landscape and portrait, and kind of tested out which one was more comfortable. I ended up going with the portrait version because that way you could hold your phone with one hand. Yeah, so here I made the stars more responsive to the gravity. I made the gravity field stronger essentially, and instead of following the player, the balls at this point just kind of move in random directions, the enemies. And yeah, it's this is way more fun, especially watching them scatter. So I decided to go with that, and this was the final prototype. After this, I just made the final version. And after you could basically say that most of the functionality was finished in this, right? Like, I'm just missing a couple things. I'm missing enemy respawn, the score, the menu, and the end screen, and that's about it, which is, like, doesn't sound a lot, but despite the fact that it seemed like I wasn't missing a lot of things, I actually threw all this code out. Like, the code for this, well, I didn't literally throw it out because you can see it right here, but I didn't use any of this code for the actual final project. The final game. It doesn't have any of this. And the reason for that is because this code was never meant to last. I didn't write it with the intention of like features being possible to add to it, because I didn't know if I would end up going with this version of the game. You shouldn't think of your game in terms of a bunch of hard-coded features like, oh, I have enemies when I smash into them, that's like a separate feature. When they smash into me and I die, that's a separate feature, etc., etc. You shouldn't think of your game as that. Rather, you should think of your game as a collection of systems that interact with each other, which is why I threw this code out and started from scratch when I worked on the final project, which if what I'm saying doesn't make sense right now, it's going to make sense in a second because we're moving on to the code for the final project and you're going to see for yourself. Going into the code for this game, first things first, we gotta talk a little bit about how Godot works. Godot uses what is called an entity component system, and if you don't know what an entity component system is, you do need to read up on that. You need to have some understanding of that to understand what I'm going to talk about right now. But basically, the Godot has an entity component system, and the way Godot's entity component system works is that a node is both an entity and a component, right? So, for example, if I have a kinematic body, sorry, it's called a character body, but functionally it's a kinematic body, and this is like enemy or something. And this is my entity, because character body, I'm gonna add functionality to it. But the thing is that aside from being a entity, it is also a component because it has a character body component. And also, if I want to add additional components, instead of adding components in here, I am going to add a node, a child node to this, which is a sprite, for example. And then I'm gonna put in some kind of sprite. Let's just pick up our temporary graphics here. So yeah, this is now a body, an entity, that is a character body or kinematic body, and character body is a component, but also the sprite that is the child, and also the node is a component of it. And that is how we add behavior to our objects in Godot. So if I wanted some additional custom behavior, I would add a custom node, and then because it is an empty node and doesn't have functionality on its own, I would add a script to it that would then be my custom behavior for this object that would also be a component. So that is why also every node in Godot can only have one script. It's because in and of itself, it is both an entity and a component. And additional components are added by adding nodes, but nodes could be also entities, and the scripts are like, especially when added to non-empty nodes, they're like extensions of that node, if that makes sense. It sounds way more complicated than it is. It's going to make more sense later, but basically what you need to know is that a node is both an entity and a component at the same time. And because of this, because script and node kind of go together with each other, in my file structure, wherever I have a script, I have a node that's attached to it next to it. So for example, here's my electron, and then there's the electron script next to it, and that's how my codes are, that's how the files in my project are structured. And in scenes also, scripts controlling the scenes are next to them. The managers of that scene essentially are right next to them. Exceptions are preloads. These are both preloads, and they're in the scripts folder. Technically, this is the preload, and it is mostly for the script. It's not really an actor. It is responsible for the sounds. We'll get back to it later. And also we have the graphics folder, which just has images, and the fonts folder has fonts. Those are pretty self-explanatory. This is just Godot's files that it uses to run projects or, build projects for Android. It's just all happening in the back. It's not really it doesn't matter for us. The reason I'm talking about all of this is because games aren't like an amalgamation of features, and this ties into the reason why I redid all of the code for this game, despite the fact that I basically had everything coded already. It's not like, so there's like a separate kill enemy feature plus a score feature plus da 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 da. Like, it's not just a bunch of features scattered around. Rather, games are underlying systems that are put through all sorts of context and then piled on top of each other in a neat way. And that's how game programming works. So that should give us a basic understanding of how everything is made here. So what I'm going to do now is I'm going to show you the heart of this game, which is our level. So in our level, we have a bunch of entities. Each type of entity, which there are 3 types of. Here you can see, music's distracting me. Here you can see this type of entity, the player, this type of entity, the electrons, and this type of entity, the neutron, the enemy. I call it the enemy in my script. So these are the types of entities, and entities are put into a separate node, and then each type of entities has its own container that the entities then, which the container is responsible for both spawning the enemies as well as holding them in it. This is a menu scene. This is the game. Oh, sorry, it's right here. So here you can see in the spawner, there's these are the enemies, yeah, spawned in here, and then in here we have the electrons. So yeah, that's how that works. Player doesn't have a separate parent to it because there's only one player. And then there's UI, which we'll talk about later. Let's turn it off for now. We don't... This is responsible for the score, for keeping up the score, and also if we touch an enemy and lose, there's like a UI that's telling us click the screen to restart, but we're gonna shut it off right now because we don't need it yet. So this is the level manager, which is responsible for a lot of things. Mainly it is responsible for calling start in our actors, as well as updating our actors and handling movement and collisions, but we'll get to that. So you might notice these new function and update, start and update functions. These are my custom functions. I am using them as a replacement for, this is the process function in Godot, and this is the, I forgot what it's called in Godot, but it's the one that, like, you call it the start. Let me see. Ready. It's the ready function. The reason I'm using these functions instead of process and start is because I want more control over everything. I might not want to call the update function inside these anymore, and yeah, I would like to have control over that. So I'm using the start and update functions everywhere except for one place, which I'll show you later. The level manager just has a reference to everything in here. It doesn't have a reference separately to every single electron and enemy. Instead, the spawners are responsible for that. And here is a reference to UI, etc. These are just updates. This is the enemy movement. Unhandled input is called on every single input, and an input is basically any interaction from the player. In case of a computer game, it is when you move a mouse, not when you click it, but when just move it like this even. Also when you click it, but you know, just movement is enough. Any keyboards press, anything like that, that is all unhandled input. And event is the type of input that you pass. For example, if you press an M key, event is holding inside of it, and the M key. And here we're checking what kind of input we're receiving. If it is an input event screen drag, which is you dragging your finger across the screen of your phone, or event event mouse button, which is clicking the mouse button, which this part is just for computer debugging. So right now, if I play Godot and I need to debug some things really quickly in the computer and I can't use my phone because I need this remote tab to check my notes, I can just click here. It does its job. It helps me with the debugging. So yeah, this isn't a necessary part. This is just debugging. If we remove this, it would still work on the phone normally. We're checking if we're playing. And we're going to talk about this later on. But if we are playing, we make the player position equal to our event position. So let's remove all of this for a second. Basically, where the event has a position wherever I clicked on my screen, and we know this event is going to have a position no matter what, because both input event screen drag and input event mouse button have a position. The player's position is going to be equal to the event's position. The rest of this is for a very simple reason. The thing is, the event position for screen drag starts at the edge of your screen. So in our case, the edge of our screen is somewhere here, right? It depends on the camera. Let me see the camera. Oh, sorry, the camera is here. But when the game's, yeah, there, see? This is 0, 0 for event position. But for player position starts from here, 0, 0 in the game world. So if I were to remove this part, my player position would get skewed by like half of my screen. So that's what that part is for. Else, if we're not playing, and let's bring back our UI here, if we're not playing, we can see this message. That is the point of the playing attribute. And basically what it's saying, if I click on the screen and the game isn't playing, wait for 1 second, which I'll talk about Clockman here in a bit, and then restart the game. So this is the code that is going to run right now. There we go. It waited 1 second and then we restarted. Clockman is my library, which isn't much of a library yet. There, it's in the scripts. Yeah, it doesn't do much yet. It is just like a way to shorten this script over here, which this script creates a timer node in the scene tree and then waits for it to run out. Like I said before, nodes are basically entities and components, and they're everything in Godot, so everything goes through nodes. So if you want to yield, you have to create a node for it, and this is what this script does. But this is quite a bit of legwork for something easy. So instead of writing all this, I just made a small library called Clockman that just consists of this one function. And where were we again? Yeah, level. We just write this and then it will yield for 1 second. I am going to expand this library in the future depending on my needs. And I'm gonna add other functions that I need often, that I need to be shortened, but right now it's just this. Because we have this kind of weird movement here, because we have basically, it's not a physics movement, you're not moving it with physics, you're not using move and slide, we just take the position of our player and make it equal to the position of our input. And that might have created a lot of issues if I had used Godot's area 2D, which is what I usually use for collisions. So instead of that, I use my custom script for collisions, This is another reason I always retain references to my entities. This is collision between enemies and the player. This is the only place I'm using a collision like this because the player doesn't collide with anything else, and the player is the only collision that is like not a physics-based collision. So we're doing that here. The way we're doing it is we take each and every one of my enemies, which is the reference to the enemies is inside the spawner, which we're going to talk about later. We take each enemy, and if the distance, if the player isn't equal to null, first of all, and the distance between the player and each one of the enemies, because we're going through a for loop here, is less than collision distance, which is hidden, which is inside the player, it's game over. And that's the way that this collision works. Player collision is just it's a constant that I have hidden inside, that I have in the player script. The player script doesn't have anything besides that because I didn't need anything here. It does have a reference to the level, but I didn't really use this anywhere. It's just I thought I might need reference to the level, so I just hid it inside the player, put it inside the player. Level is basically this. Yeah, we have that, and we have collision distance. Collision distance is written with capital letters because constants in Godot, sorry, not in Godot, generally, this is a code convention, constants should be written with snake case and all capital letters. And I'm just letting anybody who reads this code know that this is a constant. Next up, different kinds of collisions. Collisions in this game are handled basically with the physics layers. So we have different physics layers here, and these different physics layers, I have one for the player, the enemy layer, the walls layer, and the electrons layer. And the way I am figuring out what needs to interact with what, this is why electrons don't collide with the player if you pay attention to it. Here you can see that the electrons do not collide with the player. This is because they are on different... Where's the player? Oh, it's here. They are on different collision levels, collision layers. Here, the player's on the player layer, but they do interact with the player's gravity field. By the way, the gravity field is how the player attracts the electrons. And the gravity field is on the same collision layer as the electrons. And this is also why the player isn't affected by this gravity field. The way the gravity field works and the way it attracts, like, you know, a star or a celestial object, is just basically everything that is done by Godot. It is called point gravity, and you just check this box, and you know, it turns it into a point gravity, and then everything around it is attracted to the center of this object. And then you can modify the intensity. So if I put 3000 here, it's gonna like more aggressively stick. And then the radius depends on how big our object is. So if I made it bigger, yeah, as you can see, they're reacting more to the electrons, and they're reacting on a bigger radius. So that's how collisions work. But the thing is, we also have some walls on the outside of our game here, which prevent the electrons and the enemies from flying off. They do fly a little bit off the screen on the computer version, but this does not happen on the phone. Mostly, at least. And because of that, we need to differentiate between different types of collisions. And the way we're doing this is through groups. Here. Enemies and electrons are inside groups called electrons and enemies. Okay. Let's talk about more in depth about the enemies. Aside from what I've talked about here, we're everywhere except for the player, we are detecting collision through an area 2D. And like I said, we call this function here. We check that what we're colliding with is an electron, and we check that the velocity of the electron is, speed. The speed of the electron is more than 500. What's the difference between speed and velocity? Velocity has a direction. In our case, it doesn't matter. Speed is the scalar of velocity, and the scalar is what we care about. So we check the scalar, make sure it's more than 500. This is a magic number, though, now that I think about it. It would have been better if this was an attribute, but it's okay. This is not a big project, so things like this happen. And we have a health attribute here. We have health. We have speed, too, by the way. Spawner is... we have a reference to the spawner holding our object. So, yeah. Do we use this? Not really, but it's nice to have a reference still, just in case. And we just decrease our health, play a sound, and then if health is less than 1 and we're in play becomes false. And we'll also call this delete objects here, which we'll check out in a little bit. And we also add score, which again we're gonna talk about later. But let's talk about this now. So we have spawners, which are the best example in this project. You have an entity component system. The spawners both have a spawner component and spawn points component. And the spawner component for both is identical, even though these are different spawners. This one spawns enemies, this one spawns electrons. And I could have made like separate scripts for each one of them, have separate references, but I didn't really need that, even though the behavior of these spawners is different. So the reason I have the spawner for the electrons is because, first of all, I randomize their skin. They can have a couple of skins here, as you can see. And also there's a lot of them. So instead of putting them all in a scene, so if you look at our scene here in advance, you can see that we don't have them anywhere, which is why we spawn them. The logical conclusion is that we spawn them when the game starts, which is exactly what we do. And since there's a lot of them, I thought it would be way easier to both randomize it and not have to put them in meticulously every single one of them. We have the spawner here, which has a reference right here. We have the enemy. Amount is the amount of objects we spawn once per spawn. Spawn points are the locations where we spawn them, and in the case of the enemy, it's here and here. Here are the 2 spawn points of the enemies. And you also have the container for the spawn point, which is this. Then the objects that you spawn, I retain a reference to them. We've already seen why we need a reference to them. You can see it in the level, because here when we check the collisions. So I planned ahead to make the reference to those objects because I knew I would need them along the way. Technically, I do not need references in the other case, in the case of electrons, but it is still nice to have them. It was less effort to make a robust spawner that would retain reference to things that spawn, especially since retaining references to different things in your code is very important very often. Then like make separate spawner codes that would just make everything more confusing. Range is the difference between a spawn point and the place where the object spawns. So in the case of the enemy spawner, it is 0 to 0 on the x-axis and minus 1120 to plus 1120. So basically what this is going to do is that it's going to spawn it in the range on the edge of our screen, and it's the same for both sides. for both spawn points. All of the spawn points that a spawner has the same range. So here we set the spawn points, which basically means we put all the children that this node has inside this array to keep a reference to our spawn points. Yeah, that's what this is for. Here we update each object, nothing special. Here we start each object. We also spawn our objects on start, which the way that it happens is that we instantiate an object from the reference. We add it to this spawner. We add a reference to it inside our objects array, and then we set the position to one of the points randomly, plus the range. Here you can see, and by the way we're choosing them is here in point. It's going to be a random number from 0 to size of the array that holds spawn points -1, and then we make the object's position equal to the point's position plus range. And then we start the object, called the start function inside the objects, and then delete objects is something you've seen a reference to before right here. So basically each object calls this function when it's deleted, and the reason the object calls this function is so that we don't check every time if an object is in play. This is also what this bool is for, by the way. So when we know we're deleting an object, we call this function, and it checks for every object if an object is no longer in play, which again we're doing here. First of all, it's going to erase a reference to that object from this array, and then it is going to delete that object from the scene. So that is the way that the spawners work, and the only difference between these spawners logically is that one of them should spawn once per interval and the other one should spawn only at the beginning, right? Because our electrons only spawn at the beginning. There's a set amount of them. There's no way of destroying them, so there's also no need of creating new ones. So that's what we're doing here. But our enemies get destroyed, so we need to spawn new ones. And so the way we're doing this is actually through this timer component only. That is one of the only differences between the electron spawner and enemy spawner, aside from the fact that the electron spawner also has only one spawn point. And this timer, upon timeout, it calls, there we go, timeout. It calls this spawn function, which is this function, which all it does, it spawns a certain amount of whatever the spawner needs to spawn. And this timer is connected to the script. It is also connected to itself, and what it does, this code does here, is that it shortens the amount of time. So the more the script runs, this wait time of the spawner is going to be less and less, but never 0 or negative, because wait time is some number that is more than 0 and is divided by a number that is slightly bigger than 1. Because of that, it can't be 0, because you can't divide a positive number by a number and make it equal to 0 or less than 0. And the reason this number is greater than 1 is because if it was less than 1, then we would be raising the time. So 0.5, for example, first time it would be like, if wait time first time is 1 second, this actually means multiply by 2, so next time it would be 2 seconds. And the reason it is slightly more than 1 is so that the time decreases very, very slowly. So that's how this works. Speaking of references, like I was talking about earlier, as I already mentioned, a lot of things keep references to each other, and you might be thinking, why not, for example, signals? And I just feel like it's easier to use references most of the times, even though I still use signals. My general rule of thumb is, if it's like a small system that like of an object and its components, so if it's in, like, logically it is an object and its components, like this player here. Well, we don't have any signals in this case because I didn't need any, but okay, you know what? Enemy is actually a better example of this because we do have a signal here. So object, its component, the component has a sends a signal to its entity because you know, they're kind of a closed system. They're close together. No need for creating extra references or anything like that. Same logic here. The enemy spawner is an entity. It has the spawner component and it has the timer component. So timer interacts with its entity via a signal. Now let's talk about the main game. You might have noticed already that the game here doesn't have a reference to, there's no level when, or menu for that matter, when you just open the game. This is like the core of my game. This is the main part of it. And this is actually the only place where I use the ready and process functions. And then everything else, everywhere else, I have start and update instead, and they're called for the first time through this ready and this process, and then whatever is called in this ready and process is then called inside its own update function. This is a singleton, and we also have a state machine as a singleton here, which I'm going to talk about in a little bit. This just makes sure that randomize is for, you know, everything random we use in the game. This just creates a random seed for every random thing we're using. And then we make sure that this is a singleton, that it can't create any more of itself. Then the global state machine, and here are inside a state machine, and we have two states total, the menu state and the play state, and the state machine, global state machine for the game itself, must always be the first child of the game itself. And if it's not equal to null, we start it. Then in process, just like so we don't get an error, if the state machine isn't equal to null, we update it. And that's basically it. This is like the main controller of the game. And it is a singleton because we need access to it we might need access to it from down below. Same for the state machine. The way that the state machine works is it has a reference to the current state, which now that I think about it, the word state here is kind of unneeded, but you know. It has a reference to our current state, and it also has references to all of the states that it might be in. In my case, I made the states already part of the state machine at the beginning, and then each state calls its actors, which we're gonna see what that means in a little while. But so this state machine, we just like have to, if we need new states, we can just add them as children. So I don't know if we needed a game over state, and we would add a state code to it, state script. Sorry, not like that, like this. And then this would be a new state. And it just takes all of its children and adds it here, which is a dictionary, and the dictionary puts the name of the state as the key. So we add, it adds all of its children, and because of that, only states should be children of the state machine. And if they're not, then it's gonna push a warning telling me that, hey, that's not a state, it shouldn't be here. Then the first state is going to be the first child, and then we have a change state function which just exits our current state, change the state, and then, you know, enters the next state. Speaking of this, exit and enter, here we have in actors, it should be no, in scenes. Okay, yeah, it's in seeds. We have a base state, which is just a basic template for states. We have a reference to our actors and a variable that we can see in editor, which is also a dictionary, reference to our references. And we have empty enter, update, and exit states just in case. So like if, for example, in menu state, we didn't have an enter. We do need an enter function in menu state because it is going to be called here. But since our base state, we're extending base state, we're not going to necessarily need a enter state in the menu state anymore, enter function in menu state anymore, because we have it in the base state. Moving on to the menu state, we do have an enter function in this case, but it wouldn't have been necessary. So yeah, this is what I actually the play state and menu state do the same thing, so there was probably a way to not write this code twice. I did have minor differences here, so it would be less trouble to just write this code twice than think a way of how to optimize it. We have a reference to the actors that need to be loaded in during the menu state here. And if we look at our game and what that means, pay attention to the menu state here. It doesn't have any children currently, but when I play it, as you can see, it has now a main menu child. This is essentially what that code does. We have references to objects that we need loaded in. In the case of the menu state, it's just the main menu, and then it just loads it in. The main menu then has two children. Here's the menu state. It has two children. Background, which has a spawner attached to it, which just like spawns these electrons in the background, and a UI component. The UI component then has the menu, which is all of this, the thing on the forefront. The reason I did it like this is because otherwise, if I just put the menu here, the menu would draw behind these electrons here. And I, didn't need it that way. That's not how it was supposed to work. So yeah, that's why we have a main menu, then a UI component, then a menu on top of it. And I didn't have a better system for it. And I just instead of coding underlying systems from the start, I just attached a bunch of nodes to each other, and this was, despite the fact that it wasn't the most elegant solutions, it was a good solution. And some battles are just not worth fighting. Like, you could keep optimizing and optimizing your game, but sometimes it's just better to, go with maybe not the best decision, but one that is functional and works and will get you there in time. And this isn't a bad, unfunctional solution either. So there's that. So all of these actors that the states have reference to get created on enter and deleted upon exit. The same is true for play state. And then we have the start game function, which grabs the instance of our game, then gets to the state machine and changes state to play state. So when we click on the play button, it changes to play state. That's the main part of our menu. We also have a couple other buttons here, some margins. So let's open the menu separately. There we go. Yeah, we just have some, most of it is in the menu code. We just have some buttons that sends signals to our menu, and they just lead to various links. Again, probably there's a more elegant way of doing this, but this is a good enough way, in my opinion, especially for a small game like this. And then also the music toggle. So that leads us into our play state, most of which you've already seen, except the play state just loads the level. And it also keeps a reference to score. Score amount is how much you get for a single enemy Then you have a reference to score. You have a reference to the interface, the menu, not the menu, but like the score display UI through the play state, and it gets updated in the play state. It is called from elsewhere. It is called from the enemy script. It gets updated here. And then game over here. Playing becomes false. The UI pops up for when you lose. Then you delete the player and delete the reference to your player because the level, the level retains a reference to the player. Final thing I want to talk about is auto loads in this. We have two auto loads, the sounds, which holds a reference to all of the sounds, and Clockman is my library that I talked about. And we just have all the reference to all of the sounds here, and we just call this auto load wherever. I believe we just called it in the play state. Yeah, there we go, and we just call the appropriate sound and we play it. So that's about it. Thank you for watching this video. If you want a closer look on the source code for this project, it is up on my Patreon for second tier and up. Either way, thank you for watching this video. Like, subscribe if you learned something new. Here's your cut mid-sentence out.